Hi there. Let's continue solving our questions. So we shall now start with question number 5, part A, which says distinguish between parametric and non-parametric models and supervised versus non-supervised learning with examples. So let's begin. Uh, So, models in machine learning can be broadly classified as parametric, non-parametric, and parametric models have a fixed number of parameters regardless of the size of the dataset. They assume a particular functional form, such as the linear form for linear regression, and non-parametric models, on the other hand, allow the number of parameters to grow as the data and do not take strong assumptions about the form of the underlying function. Decision trees and k nearest neighbors are prime examples for this. Similarly, in supervised learning, we have provided a labeled data. We are provided basically a labeled data set. Our objective is to learn a mapping from inputs to outputs, and classification and regression fall under this category. The unsupervised learning, however, by contrast, operates without labels. There is no labels. Here we aim to uncover the structure inherent with the data, that is the underlying rules and underlying relationships. So clustering, dimensionality reduction, and associate rule mining are prime examples for unsupervised methodologies. So let's solve the next subpart. Define accuracy, precision, recall, F1 score, and illustrate their computation using a confusion matrix. So again, this is a simple question. We can start by first evaluating what is a um, we can start by discussing about how do we evaluate classification models. So when evaluating classification models, we rely on some metrics derived from this confusion matrix. As you can see, there is a predicted positive rate, there is a predicted negative, there is an accurate positive and an accurate negative, the intersection of which are the true positive, the false negative, the false positive, and the true negative. So, actually, this describes the proportion of total predictions the model gets correct. So, accuracy is basically the proportion of total predictions that the model has gotten correct. That is the true positive plus true negative divided by the summation of true positive, false negative, false positive, and true negative. So, all the predictions made upon the which will be the denominator. Here for our example, it is the 85%, the accuracy is 85%. So overall correctness is around 85%. Similarly, precision focuses on positive predictions and measures the proportions that are correct. So we in precision we are basically measuring how many positive predictions are correct. So we define this as true positive by true positive plus false positive. So here the true positive rate is 45, and the summation of true positives plus false positive will be 45 plus 10. So we get the precision as 81.8 of predicted positive values, like how many were correct. So that is the measure. Recall measures the proportion of actual positives that the model successfully identifies. So recall is basically the true positive upon the true negative, the true positive and false negative summation. Here our false negative is 5, and true positive, as we have seen, is 45. So this gives us 90% of actual positives. How many did we identify? This is the measure of recall. This is also called sensitivity. F1 score basically provides a harmonic mean of precision and recall, and is particularly valuable when dealing with imbalanced data sets. So in here we multiply the precision and recall by 2 and divide it by the sum of precision and recall. So that is 2 into the precision value. Instead of using the percentage value, we are going to be using the fraction value. So 0.818 into 9 into 0.90 by 0.818 plus 0.90. So this gives us a F1 score of 0.857. This is the harmonic mean, and it is particularly valuable for imbalanced data sets, right? So when false positives and false negatives have similar cost, medical diagnosis, fraud detection, often prioritize recall, while the spam filtering may prioritize precision values first. So this was the confusion matrix example, and this solves our fifth question. The next question we shall solve in our consecutive video. Thank you for watching.